Right, grade 12. Let's look at trig equations involving compound and double angles. So what if I said to you here, let's make up one quickly here. I said to you the cos of x times the cos of 10 degrees minus the sine of x, the sine of 10 degrees is equal to -1. And you've got to solve for x here. How on earth would you do it? No calculator, and you've got to solve for x. Well, do you remember the formula that said if you had cos A plus B? Do you remember that this is on the formula sheet? It was cos A, cos B minus sine A, sine B. Okay, now we can apply this. So if that was x and that's 10 degrees, x and 10 degrees, we can go backwards and make this x plus 10 degrees. So this equation could become the cos of x plus 10 degrees is equal to -1. So you're using a compound angle there. Now we go back to our normal trigonometric equation. So it's x plus 10 is equal to plus minus shift cos of -1 and plus k 360, where k is an integer. Okay, so remember you keep the whole angle, and it's plus minus with cos, shift cos of the number there, plus k 360. So that would come to x plus 10 is plus minus the shift of cos, that would be 180 degrees. There we go. And we go plus k 360. You can check that in the calculator. And off we go. Okay, and now we've got the two options here, so we can say, okay, fine, like we did in grade 11, x plus 10 is equal to 180 plus k 360. That's the one option there. The other one would be where x plus 10 degrees is -180 plus k 360, you see. Okay, well, this is easy. X is equal to 180 minus the 10 is 170. Plus k 360, there's your first general solution, and this would be equal to 10 goes across, -180 subtract 10 is -190 plus k 360, and there's your general solutions. A wonderful link to compound and double angles. Okay, alright, how about this one? Try this one. Here's a lovely double angle here. The sine of 2 theta plus 2 sine theta is equal to 0. So how are we going to do that? With much difficulty, some people might say. But think about it, it's actually not that bad. Not that bad at all. Okay, so what we can do is the first thing is, it doesn't help bringing it across, that's awkward. But sine 2 theta can be written as 2 sine theta cos theta, okay, and plus 2 sine theta. So that's your first mark there to do that. I think I can get rid of those 2's if I divide throughout. So it's sine theta cos theta plus sine theta is equal to 0. So in essence, what I could then do is to say, well, okay, great, I can take out a common factor of sine. Have a look at that. And I'm left with cos theta plus 1. There we go. So I'm fundamentally now breaking this up into two parts. The one is sine theta is 0, or cos theta is -1. And of course you can then use your rules. Now for sine, if you remember here, let's just focus on the sine equation here. Okay, if we look at sine theta is equal to 0, remember the trig equation said theta could be shift sine of the 0 plus k 360. Okay, we'll put k at elements of z for everyone. So that gives you then 0 plus k 360. There's your first general solution there. Then the other option with sine, of course, is theta is 180 degrees minus the shift of sine of 0 plus k 360. Okay, so this comes to 180 degrees minus 0 plus k 360 that you've really worked out, and you land up with 180 degrees plus k 360. And there's your second general solution for that equation there. Okay, what a pleasure. Okay, now what about the cos of theta? Well, if we focus on that, cos of theta is -1. Well, remember with cos, the theta now is plus minus the shift cos of that -1 plus K360. So you just got to know these rules. So theta would be plus minus 180 degrees if you work that out, plus K360. There's two general solutions here, a total of then 4. Okay, very lacquer linking this to compound and double angles. Okay, should we explore another one quickly? Let's have a look. This could be very cool if we have a look at, let's take another one here. Say, for example, I said to you, now this is a tricky one. Okay, this is going to be more involved. Solve for theta if you've got 3 cos 2 theta. There's a double angle. Here's a double angle minus sine 2 theta is equal to 1. I'm giving there's another restriction here. Tan theta is bigger than 0 or positive, and theta is going to be restricted between minus 180 and 360. So there's two restrictions here. That's tan is positive, and at the same time we've got a restriction on theta. There's an advantage of this you'll see in a moment, but let's look at our trig equation and let's try and explore what we can do with our double angles here to try and work with this. Okay, well, firstly, what I could do is say, well, seeing that sine, if you look at the sine 2 theta, it's really sine theta cos theta there. Okay, 2 sine cos. I think for me it would be probably easiest to use the formula cos squared theta minus sine squared theta, all for cos 2 theta there. Okay, now if we distribute this out, let's multiply that out. I'm going to do this fairly slowly. Multiply that out. Something very interesting is going to happen, and this is quite a tricky one. Okay, sine theta cos theta, and that equals 1. Now, wow, this is going to become a little bit awkward, and I want you to watch this carefully. There's almost nothing you can do here. Now, what I want you to focus on is a wonderful little trick that you can possibly use. This is quite a high-powered one, but sometimes asked. I want you to look at this. If I take the 1, okay, and I convert it to sine squared theta plus cos squared theta, if I do that, if I convert that 1 to this, something interesting is going to happen. What it means is that you can then, you get a little few like terms. You've got 3 cos squared minus the cos squared theta. If you bring that across, then you've got -3 sine squared theta, and then if you bring that sine squared across, you get this. Okay, and then we've got -2 sine theta cos theta, and that is equal to 0. Okay, because you brought these two across. Okay, now let's collect the like terms. Watch this. 3 coses minus 1 cos is 2 cos squared theta. This is -4 sine squared theta, and you've still got -2 sine theta cos theta, and that equals 0. Okay. Alright, now let's have a look. I can divide everybody by 2 to simplify life a little bit for me. Okay, and I can divide that by 2 as well, and divide that by 2. And of course we've got, this is probably one of the very good equations that could appear. And then if you rework this, you could get a thing like this. It says there, you've got your cos squared. Now I want to show you something. Cos squared minus sine theta cos theta, and then you've got -2 sine squared theta is equal to 0. Now what does this remind me of? Think of this. What is a squared minus ab minus 2b squared? That's a trinomial, and you probably remember, hopefully, how to factorize this. You could have a minus, whatever, 2b and b. Now let's see. So that would be negative and a plus if you factorize. A squared minus 2b squared minus 2ab plus ab is minus ab. So if we apply that principle here, think of cos as a. That would be a minus 2b and a plus b here. If we use that principle for this, what we can then do in a very simple way is say this is the cos of theta, like a, minus 2 sine theta, and then cos theta plus sine theta is equal to naught there. Okay, so it's simple applications of your little trinomials there. Okay, good. Now, what we can then do is we can say then cos theta is equal to 2 sine theta, or cos theta is equal to minus sine theta there. And now the trick with this is where it becomes a little bit more tricky. This is one of the most, this covers everything you need. I can't work with this, so what I'm going to do is I'm going to divide both sides by the cos there. And also here, let's divide by cos on both sides, and you'll see the value of doing that, because that gives you 1. This is 2 tan theta, because sine over cos is tan. This is 1, and that equals negative tan theta there, sine over cos. Okay, great. And if you divide both sides by 2, look at that, you got tan theta is a half. Bring the tan theta across, and the 1 across negative 1. And we've now got 2 tan equations that we can deal with. Okay, now we just apply the rules. So for this one, remember theta is shift tan of that a half plus k 180. And this here is theta is shift tan of negative 1 plus k 180, where k is an element of z. Now, if you work out this, we'll probably, they would also have said, let's round off. They didn't say much, so we'll round off to maybe 1 decimal place. This comes to 26,6 plus k 180 there. So there's your one general solution. And this one over here gives me theta is equal to negative. And by the way, actually, if you worked it out, you don't have to worry about this. This is actually cool. That's why that restriction was good. So we can actually forget about this. What a pleasure. We can actually say, I'm just going to remove that here. This you can actually go away and say, why go ahead with all this? What is the reason for that? Unnecessary. Because if you look prior to this, it said there, if you go right up there, tan is positive over here. So we don't want to even worry about this. So this is not valid. We don't need that. Great. So there's the general solution that we need. And then, of course, they've given us another restriction up the top here. If you have a look there, minus 180 to 360. So if theta goes from minus 180 to 360, we've just got to select some values for k. And should we do that? What a pleasure. So we can draw up a little table. Well, in this interval, we could say, let's look at, say, k is equal to minus 1, k is equal to 0, k is equal to 1. And if we do that, well, what would this be? That would be, if you take your general solution here, 26,6 plus k 180, this would give you 26,6 if k is 0. And then 26 minus that would give you minus 153,4. And then if you add 180 plus one of those, if you substitute that into there, this will come to 206,6. And in fact, you can try negative 2 won't work and 2 won't. And then you've got your little values. So then these would be your solutions. So you could say that theta would be, we can put it into from smallest to biggest if you like. There, 26,6 and 206,6. And there we go. Wonderful. This is probably one of the most challenging because it's really got a whole lot of things in there, trinomials, everything. So really go through this again. It's quite a good question, guys.